Okay, so how many valence electrons are in carbon? So let's write it out, and it does say the answer there, but I'm actually gonna walk with you through this question. Electrons in carbon. And let's just also pick another one, like something not so stressful in the periodic table. Sulfur is a pretty good one. Yeah, I like sulfur. Sulfur. So the reason why I'm adding sulfur as well is because the way you actually solve these questions is through their electron configuration. In fact, not even sulfur. Let me pick a tough one here. Let's pick tin. I like tin because tin is also one of the weird ones, but you'll see how it works because these questions can get complicated. So as a basis, we're going to start with carbon. The way you figure out your valence electrons, okay, is by writing down the electron configuration. You could technically just look at it as well based on the periodic table, but this is like the surefire way of making sure that you're not wrong. Okay, so carbon, okay, if we wanted to write the shorthand version, we started helium. In fact, let me just say what I'm actually writing. So electron configuration. Okay, so now, as I said, carbon, right, starts at shorthand helium because it's a noble gas right before it. And if you notice, it has 2s2 because lithium and beryllium are filled. And as you get to boron and carbon, it will be 2p2. Okay? Now, to break it down, the 2 indicates like what row, like what shell it's on. Okay? The big 2 in front. And the small 2, the superscript, okay, that one represents how many they are. So to find out how many valence electrons, you add from the biggest number of the shell they're on, you add the superscript numbers. So you get here, okay, that they have 4 valence electrons. Okay, and you know what? Let me actually pick. I think I'm gonna pick iodine for this one. Yeah, something a little bit more structured and stable. Okay, so iodine. Now, if we were to write that one out, as we do in shorthand, we first want to start with the noble gas that comes before us. That'll be krypton. Okay, and now it's going to be, because now we have to go through rubidium and strontium, it'll be 5s2. But now when we see the middle row, actually there, all the transition metals, that one's referred to the D row, and you have to subtract 1, so it'll be 4d10 because it's filled all the way. And if you count, there are 10 atoms you have to go through. And then to get all the way to iodine, it will be 5p5. Okay. Now the reason why this is really cool, because you're gonna notice soon, we reorganize this because we want to make it make sense. We put the smallest number in front, as in like the row it's in, so 4d10. So the smallest front number, not the superscript. Okay. And 5s2, 5p5. Okay, and now you notice the 5's together. This is your valence electrons, and you still have to do the same thing of adding the superscript together, and you get 7 valence electrons. Okay, now the reason why I'm pointing all of this out actually is just because if you notice, right, okay, this is for carbon and this is for iodine. Okay, if you actually look in the periodic table, right, carbon is on the 14th row, and most things on the 14th row have 4 valence electrons. If you actually look at the periodic table, if you think about it, it goes 1 for 1 valence electron, 2 for 2, but then it skips the transition metals and goes straight to 13 for 3, 14 for 4, 15 for 5, etc. up until you get to 18 for 8 valence electrons. That is a full shell. So that's as I was just breaking through, it's kind of like you can use both ways. The electron configuration, 1, yes, or you can look in the periodic table, and once you get past 2, whichever number it is, like 13, 14, 15, 16, 17, and 18, you subtract the 10, and that should tell you usually what valence electrons they have. So oxygen, for example, is on the 16th row, so that's 6 valence electrons. Okay, let's see if I explained it right, hopefully. Exactly. Wow, they even mentioned that. So there are 4 valence electrons in carbon. They mentioned the configuration. 1s2, that's also, you can write as helium, because that was a shorthand version. 2s2, 2p2. Yep. And you see here exactly that, just as I said, they skip the transition metals, and once you get to 13, it goes like you ignore the 1 in front of it. So 3, 4, 5, 6, 7, and 8. And so yeah. And they mentioned that exactly the exception is helium, because helium, its shell, I guess for context, the first shell, so hydrogen and helium, that one only takes 2 electrons total. It doesn't go up to 8, it only goes up to 2. So yeah. Okay, so this is correct. Okay, now let's go on to question 7.